Hey everyone, welcome to our talk, and thanks for coming. My name is Surya. I'm an engineer working at Red Hat on the OpenShift networking team.
And I'm Dan. I also work at Red Hat on OpenShift networking.
So we're here today to talk a little bit about kubelet probes. It's an informal talk, so we want to make it more interactive. If there are questions you want to interrupt, please feel free to raise your hands. And this is not a monologue where Dan and I are going to talk things. It's about also getting feedback from all of you. And this is centered around the KEP 4558 that I have linked on the slide, 9.
I realized 4558 is the PR request.
The issue number, yes.
4559.
So 4459 is the KEP number, 8 is the issue number. So we're actually here to talk about some of the problems that probes have today, especially with regards to networking and network policies. And the KEP outlines all of that in depth, but we've tried to consolidate that into the slide deck today. So firstly, I'll be talking about some of the motivation behind even thinking about probes, and redesigning probes is a huge word, right? Like in that sense. But then we're going to try to talk about some of the problems that are existing today with probes, and Dan will cover some of the potential solutions that we have in mind as part of the KEP. But again, those are not set in stone, which is precisely why we have this talk today. We're hoping to hear from you and to incorporate that feedback. Maybe there are other ways of solving the problems which we haven't thought about. So this is a brainstorming session, and we would definitely love to have more co-authors and contributors from the SIG node community, because Dan and I are from SIG Network. We don't know what we're doing with the CRI and the kubelet side of things. So we would definitely love your feedback, and also maybe if you are volunteering to help us out, that would be awesome. So for those of you who do not know what probes are and are coming to the Maintainer Summit for the first time, and for new to Kubernetes in general, I would like to give a TLDR. They are simply health monitoring diagnostic tools used to check the health of your pods. And there are different types of handlers, both for the lifecycle management of the pod and the probing of the pod, like the exec probes, HTTP probes, TCP type, and gRPC. And there are mainly 3 types of probes. Startup probes, as the name suggests, is used for knowing if this application has started up, especially used when you have an initialization process and it's going to take longer for your pod to come up. In that case, you can use startup probes to know if your application has started or not. And if it hasn't, and if the probe has failed, the check to know if your application has started up or not, the pod goes into a failed state. So that's literally what startup probes are. The second type is the readiness probes, usually used in conjunction with services. Usually when your pod is a backend to a service or an endpoint, when the readiness of the pod has not succeeded, which is the pod ready to receive traffic, is the TLDR there, it doesn't join the endpoint slices group, right? So it stays there in failed state, and based on your parameters of how many times you're checking for the failure state and how many times you are going to do the readiness probe, this will continue to retry. The last one is the liveness probe, which is the third type, which is commonly used to check if your application is healthy. Is it alive? Are you having any crash loop backoffs? Are you having any restarts? Is there a deadlock? Is your application alive? And if yes, we continue, things are good. If no, based on the parameters, again, it restarts to make sure that your pod is healthy. This is like a very nice feature. These are the 3 types of probes that we have in Kubernetes today. And getting to the problem statement and the crux of our talk here is, how do probes work with network policies? I think and Dan mentioned this, I wasn't there when network policies were designed, but when network policies were designed, I think by design it was kind of documented that the kubelet should always be able to reach all pods on your cluster. And this is because there is no good way to solve this problem in general. But really, when the Kubernetes networking is open by default, and one of the main reasons for using network policies is to restrict traffic to your pod. So when you do create a network policy and you have an ingress deny default, I think the expectation is that you only want to allow traffic that you want to be allowed. But in this case, anything from the host gets allowed. So you have to open a hole from the host for kubelet probes to work. And this is documented, and all CNIs expect this, like SIG network expects all CNIs to implement it this way. But maybe we can do better here, right? This is by design, and one of the reasons why this came up is because we also have admin network policy API, which is the new API that is out of tree, which is network policies for admins. And there today we don't support ingress from the host, but if we do, we didn't want to make the same assumption for the user on their behalf that kubelet probes are expected to work for pods with policies in place. The second use case here, or the problem, is with dual stack clusters. There's been issues opened by our community users and members around how it's not possible for kubelet probes to have a way to define which pod IP you want to do the probing at. By default, it's the v4, but what if the application is only v6 aware? Maybe it doesn't know v4, right? In that case, for IP families, there's not a convenient, good way to do this today. Maybe you can use the host field and have a local host set to your v6, but this is not intuitive. So maybe there is another way by redesigning probes where we can solve this problem. And an extension of that is also when you include multi-networks on pods, right? There is a SIG network, multi-network working group that's working on some of these aspects. But what if the pod actually has more than one IP? And Kubernetes, today the core Kubernetes is not aware of any of these concepts. And it defines that you have to have a unique pod IP in your cluster. And if the pod has more than one IP, if you want your probe to work on that IP, there is no way to do this, right? It's the same as the dual stack issue. And the last one, which is interesting, is the overlapping pod IPs. And like I mentioned, by default, we expect in networking for Kubernetes that all pods in your cluster should have a unique IP. But this is not true anymore with a lot of ecosystem projects. A lot of CNIs support having more than one pod with the same IP for multiple use cases, especially in context of multi-networking. And in that case, kubelet doesn't know because it assumes that all your pods should have a unique IP. And I'm a maintainer of the OVN Kubernetes CNI, where we implemented an opinionated way of doing multi-networking. And as part of that, we support overlapping pod IPs. And we had to get around this problem by doing a hack of sorts, because we had to keep the default network as is. So nothing is allowed on the default network except kubelet probes, which is the ETH0 interface that you see there. The primary interface for the pod is the UDN0, right, which is where we would love the probes to work, but doesn't, because kubelet is not simply aware of this. But maybe this is also one problem to consider with DRA and everything that's happening. How will probes work for these extranet devices on your pods? Can we solve it by rethinking how probes work, or maybe redefine the semantics a bit? And the final one is the security loophole, which has been a long-standing issue in Kubernetes. There is a host field in your probes, and this host field can be set to basically anything. Anything in your cluster can be an external endpoint, could be a load balancer IP, which was the primary use case for wanting the probes to work at that endpoint. But kubelet is not going to verify what that is. It's simply going to probe that endpoint, that IP. And this can lead to server-side request forgery attacks, which is bad. So maybe we didn't think this the right way when we designed it. So now we are rethinking this, right? Like, how can we prevent users from shooting themselves in their foot? And now it's like a fun question for all of you. If you were to put the local host IP here, 127.0.0.1, what would you expect your probes to do? Would you expect it to be probing the local host of the pod? Raise of hands if you think that's how it works. Actually, it's the local host of the node, which is not intuitive, right? Like I saw two of you raise hands, and it's really not intuitive because maybe people don't think, but you're basically telling kubelet to probe the node, and also you can even probe the etcd metrics endpoint or some other local process running on your host. So this is a huge hole in security in terms of how it's done today. But we have a stopgap solution in the interim, which is the KEP 4942, which is a smaller version with SIGAuth, where we're trying to add a pod security admission, where admins can use the enforced model or the restricted model to define how this should look like. And this is a sample work in progress PR that I have. So if you create a pod with the host field set, and if based on what the admin has, you will get this failure, right? So you can even block users from being able to create the pods and to warn or you can even have it in the warn mode or audit mode, saying you're setting a field that has a security loophole, right? So that's like an interim stopgap solution. The reason why we're doing this is because you have no way to deprecate APIs in Kubernetes. They live on forever. Maybe you can deprecate it in the docs, but that's it. You can't really block the API or remove that field. There is no good way to do it, so we're adding a PSA as a stopgap solution. But yeah, over to Dan for talking about some of the semantics and taking it away with the potential solutions.
Thanks. So broadly, there are two different approaches that we could take to trying to fix things. One is that we could keep the semantics exactly the same, but make them better somehow, and then we can reuse the existing probe types. But if we want to change the semantics, then we have to worry about API compatibility, and so then it might be necessary to deprecate the existing probe types and introduce new probe types that do the same things but with different semantics. And we're not totally sure exactly where the boundary between those two approaches are. There are some things that seem pretty strongly API-like in the semantics of probes. They can't be blocked by network policy. They answer the question, is the serving process running? That's the main thing that probes do. People also think of them as answering the question, is the pod connected to the pod network? And it sort of answers that, but really all it tells you is, can kubelet on the same node as the pod talk to the pod over the pod network? And that doesn't mean that any other pod on the same node could talk to it, because it's possible that the network policies aren't fully programmed at that point. And it's possible that no other nodes can talk to it, because the probe doesn't check that at all. There's another thing called pod readiness gates that let you program your own more complicated startup, liveness, readiness, whatever checks. But the third API-like thing is that probes are sent to pod status pod IP 0. In particular, they are not sent to localhost. And what this means is that it's possible to run a pod that is only listening on exactly one IP address, and it will be able to answer probe requests. And so if we change probes to probe a different IP, like localhost, that might break some existing pods and would require us to do the non-backward compatible solution. Hiram's law, which some of you may be familiar with, says that basically any exposed behavior eventually becomes an API. There may be people doing incredibly weird things, like having their server respond differently if the client IP is the node IP, and only doing the health check case in that case and doing something different in another case. That would be really weird, but it theoretically is something people might do. Likewise, people might be assuming somehow that probes come from outside the network namespace, like maybe they have eBPF on their ETH0 that answers the probe somehow, and so if we change the way it worked, it would screw them up. So these are the things that we have to think about with the solutions. So the solutions. These are all suggestions, ideas. We're looking for feedback. If you have, even right now during the talk, like if you're like, oh, this can't possibly work because of whatever, or, raise your hand or something, or go up to the mic. We should have time for questions at the end too. So potential solution number one. CRI has a port forward function where you say, I want a connection to port 8080 on this pod, and CRI will open a connection within the pod's network namespace. It actually opens it to localhost, which ends up resolving to either 127.0.0.1 or the IPv6 version, ::1, depending on what's available and what works. And then you can send bytes over the gRPC connection to CRI, and CRI will forward them to the pod and forward the result back. So it's like having a connection to the port, but it's actually tunneled through gRPC. So this solves the network policy problem because the connection never goes over the pod network. It's going directly into the pod. It solves the IP family problem because assuming that your pod is listening on localhost at all, it will work with either IPv4 or IPv6. It solves the overlapping IP problem because we don't care about the pod's actual IPs. We're just going into its network namespace and connecting to localhost. It doesn't require changes to CRI because we already have this method. And the change to kubelet isn't that big. You're just changing your net.dial call to a gRPC method. Cons, it changes the probe semantics. It requires the pod to be listening on all interfaces, or at least to be listening on localhost. It results in more CPU usage from CRI because it's actually copying packets back and forth between the server and kubelet, which also makes it less efficient. Side note there, it's possible that we could, make this work slightly better. You could use an eBPF program to splice sockets together to get CRI out of the way, or maybe hand a file descriptor over a socket back to kubelet so that, again, to get CRI out of the way. So there are possible fixes there. Solution 2, what if we just give up on probing over the network and say we'll use exec probes for everything? So if your pod definition says I want to use an HTTP GET probe, kubelet would just instead do an exec probe that runs curl inside your pod. So again, pros, it solves the same set of problems because again, it would just be curling inside the pod network namespace. Doesn't require changes to CRI. Unlike the previous solution, it doesn't cause extra CRI CPU usage. Changes the probe semantics in the same way as the other one. As another con, we've heard exec probes are slow, and if there are people heavily involved with CRI, yeah, okay, I'm seeing people nodding. So exec probes are slow, so you wouldn't want to do this. And then, of course, the other thing is it only works if you actually have a curl binary in your pod, which not all pods would have. So kubelet would have to do something weird, like attach an extra volume to the pod that just contains a curl binary so that it would have access to that, and that seems kind of weird. We thought about you could do a slightly lighter weight version of this. Rather than actually doing a full exec probe, we could add a new API to CRI that just does nsenter-n to only change one of the namespaces, but would otherwise be very similar. And this is also nice because then it doesn't require you to have curl in the pod because you can just use whatever binaries you have on the local disk. Other than that, it's fairly similar to the previous solution. And you seem to be nodding that you like it. So I think maybe the third point in the cons maybe doesn't actually solve the exec probe performance problems. It sounds like you're saying it does solve those problems. It'd be better. I mean, you're still starting up a curl binary, whatever, rather than just doing it. Right. It's not involving an OCI runtime thing, is what Peter was saying there. Potential solution 4, we could add a big heavyweight probing API to CRI, where kubelet would just say, okay, this pod has a gRPC probe request with these details, go do that for me. And then CRI would periodically probe and report status back to kubelet, possibly as part of the existing status reporting check stuff that kubelet does. Solves the same problem, probably more efficient than having kubelet constantly poking CRI. Same changes to probe semantics. This requires a big new CRI API, and maybe it's too big. Like maybe we don't want CRI to know that much about probes. If we had done this originally, then when they introduced gRPC probes, people would have had to make changes to both kubelet and CRI, and then that would have delayed the implementation because we'd have to wait till everyone had a new version of cryo or containerd. So this might not be the best solution because of that. The last two are a little weird, I think. So one idea was that we have this problem with network policy because you can't distinguish kubelet probes from any other connection coming from a host network process. So what if we moved the probing out of host network into a pod network pod? So in this solution, kubelet would launch a pod that just existed to do probes for kubelet and report status back. In this case, you can recognize specifically what requests are coming from that pod, and so you could use admin network policy to say, this pod is allowed to talk to every other pod to do probing. To minimize the privileges that the pod had, you would probably still want kubelet to do the actual updating of pod status. So this is closer to the current semantics, and maybe we could do this without having to add new probing API. Doesn't require changes to CRI. When we brought this up to SIG-Node, some people were excited about it because if you're doing a managed Kubernetes platform, the fact that Kubelet does some like platform work and some end user work for the probes is bad for accounting reasons, and they liked that this would move all of the probes into a separate process and make it easier to do the cost accounting. Cons, if you do it with a host network pod, it doesn't actually get you any closer to solving the network policy problem. But if you do it with a pod network pod, it only works if you have an admin network policy in place to create to allow the connections. It's weird for Kubelet to be launching this pod. Like that's one of the big downsides, it seems to me. And then if this pod gets compromised, well, you have an admin network policy saying it's allowed to talk to every other pod in the cluster, and that's kind of bad. So we would have to be very careful about that pod. And then the last one is, rather than having a probing pod, we could just attach a sidecar to each pod that does the probing. This is kind of like the making CRI do it, except we don't have to change CRI at all. Kubelet would just attach an extra ephemeral container to each pod. That pod would do the probing and report back to Kubelet. So it has a mix of the pros and cons of other solutions. It solves the same problems. It doesn't require changes to CRI, but it changes probe semantics. And again, we have this weirdness that Kubelet is now suddenly managing these other things that it didn't used to have to manage. So that's what we have. And then the questions, this is just sort of restating what we said at the beginning. Is this really a good idea? We wanted to solve this for admin network policy so that we don't have to make a rule that says admin network policy does not affect this one particular set of connections, and there's no way to make it do that. Other stuff got pulled in as we started looking at it, but how much do we want to solve here? The security problem is pretty much already fixed with the PSA thing. Maybe the IPv4 versus IPv6 thing isn't a big enough problem for us to care. So that's what we have. We would like feedback, questions, concerns, help. There is a mic out there for.
Yeah, thanks for all the context. I feel like there's like a fundamental disagreement between two of the different like concepts that we're trying to balance here, whereas like what is the purpose of a probe versus how to do this probe really efficiently? Like if like the network policy piece of it is like, is the probe reachable via network? Any of these like optimizations that we make basically mean that we're not answering that question. I personally, CRI maintainer, like the idea of a special case CRI call for it, just because that's more idiomatic and allows us to handle it closer to and like get more efficient. But
like this one?
I like this one. But then the problem is like this is answering can the CRI implementation talk to the pod's network, not can anyone talk to the pod. So it almost feels like we need separate mechanisms to like answer both those questions.
Yeah, so I guess the assumption here was that internally this would be doing one of the other solutions, like the port forward or the NSEnter or something.
Well, but even so, that still doesn't answer the question, like, can a pod within the network contact this pod? Yeah,
and I had talked about that here, the second point on the APIs like semantics. People want the probe to mean, is the pod reachable over the network? But it only answers one small part of that.
Right.
And maybe we need a better, is the pod fully reachable over the network thing.
Yeah, I'm perfectly happy with the answer to this question being, we can ignore that for the purposes of this. Like we just say, like, that's not the question we're answering, so like do something else for that. That's fine with me. But I think we should make that clear in the design proposal.
Yeah, definitely need to make it clear.
Well, if we pass a contract down to CRI, we can pass that contract down to CRI, so the network provider can actually test via test whether or not, right?
Yeah, so Mike is suggesting that we pass basically from the CRI to the CNI and have the CNI be the entity that's doing this checking, right? Which I agree that there's a degree of like I can imagine a world where the CRI is taught how to do this probing, and then CNI is doing something funky, like this, like ETH and then UDP separate network thing, and the CRI is actually not the entity that knows the best about the networking architecture of the pod, and maybe it really should be answered as close to the deciding like entity as possible.
That can't really happen though, as long as CNI is fully exec a random binary based, because you don't want to have to, have every probe jump through all those hoops.
And then there's also host networking, which has just been mentioned.
Sorry, did you have more, or?
I was just relaying something that was mentioned back here, which is that there's also host networking, but.
Right.
My biggest feedback, please don't even consider the situation where you bypass the runtimes. Because like if a kubelet doing something over the head of runtime, it means what you are losing like implementation of different runtime handlers. So like if you have anything implemented as a VM per pod or anything in confidential containers, trying to NS enter to something from the host doesn't bring you to the actual namespace. So trust the runtime. Ask them to do a thing for you. But don't try to go and assume how it's implemented.
I think in the KEP, it actually, like in the NS Enter one, there's a footnote saying, obviously this only works for, Linux container-based runtimes, but we could consider this to be an optimization on top of one of the other things. Like, if you're on Windows, then it would just use an exec probe.
Well, even in Windows, if containerd implements something like a port forwarding to the appropriate namespace or whatever is called in the Windows world, anyway, like don't assume how the container is implemented on low level. We have API, we have a contract between the kubelet and runtime. You need to something in addition to that contract. Let's change the API. Let's not override it from external.
Right, like the plan with the NS Enter one was not that Kubelet would be doing that. It was that Kubelet would invoke a CRI API that would have a lighter weight exec semantics,
Hi, yeah, probably missing something, but you mentioned briefly the possibility that the admin network policy might not be completely programmed before the probe executes. What's the big deal? Like, could you just say if you want to use a probe, you have to have an admin network policy that allows the kubelet to talk to the pod? Is that bad?
It's not great, and it's not backward compatible. So that would force us into one of the solutions where we have to do an API break to introduce the new semantics.
That makes sense.
It would catch people by surprise, in some sense. It would catch people by surprise if
Right.
you didn't. Suddenly you'd have a cluster with everything failing till you had that created. So
Yeah, that makes sense. Thanks.
So yeah, like this, would be really happy to see something like this change. I guess one clarification question and then one suggestion question. Clarification question, I felt like on the cons for every option it seemed like the semantics were changing. Did I make that up, or did I miss one?
the beginning actually.
Oh, okay, 5 doesn't have it. Okay, awesome. The second question I have is on, the probing pod. I like this option. I'm wondering, I know in some places in Kubernetes there are static pods that are created. Does that help at all? Is that what we'd be proposing here? Is there a reason a static pod wouldn't work here?
So if you want it to be pod network, then it can't be a static pod,
right.
really.
Okay.
It's at least not well defined in that case.
Okay, thank you.
Hello, thanks for the session. So it seems to me that there is quite an interest about using a variation of exec probes. So this is quite a hot direction. But in that case, there is one specific use case about the containers which have very low latency requirement with those careful pinning, and something execs into that disrupts basically all the latency guarantees. So just I think just an heads up to take this case into consideration, because it's kind of limited, but when this happens, disrupts pretty much everything. I guess it could be solved somehow with the runtime help if there is maybe a new, I see Peter nodding, a new CRI option to run something in a specific CPU, but still this is something that when people say exec probe, quite some people,
Yeah, like the basic exec probe idea, I think the performance just wouldn't work. So that was sort of suggested because it's simple to explain, and then we had the improvements on that as the other things. But yeah, the basic exec probe version, I think, is not a possibility. So.
But we have exec probes today, right? Which have the same.
But people choose to use them, and
Not terribly efficient.
Hey, a couple things if I could. Can I just clarify first, is this just focusing on HTTP probes, or is the idea here that as part of this you may re-architect exec probes as well?
Yeah, so the three network probe types, HTTP, TCP, and gRPC, would all be covered by this.
But
we were not looking at exec probes at all.
Right, okay. Second thing, I haven't thought this through, but as a possible solution, is something along the lines that's similar to like the pause container a possible thing here? Like a container that's run within that same namespace, but yeah, similar to this, but not necessarily exposed, not needing to be exposed through the API perhaps, but like just in the runtime on the node.
Yeah, so it, again, in the KEP, we go into more detail on a lot of these things. And yeah, the idea was that this would not necessarily be visible to the end user. I had actually originally suggested, we could just make the pause container do that. And then people were like, no, that's going away.
It's going away.
I don't know, someone said that.
Trying, working on it.
Oh, okay. That's news. Okay, thank you.
Related to the ephemeral containers, could you go over the pros and cons of the sidecar solution? Again, because I have you really investigated that, or I came from I did Istio for a while, so I'm kind of somewhat fond of sidecars.
So the pros and cons of it are not particularly related to the use of sidecars as a technology. The big con, I think, is that it's weird for Kubelet to suddenly be creating this thing on the user's behalf without the user knowing, and then having to manage it. Like, what if the sidecar crashes? So that's the thing that makes that weird. And then, all of the other changes, semantics, depending on which IP it's probing. But yeah, it's not really about the sidecar in a way that is related to the Istio's use of sidecars. It's like whether they make sense for this use case.
Okay, and can I ask another question? Maybe this has been done before, but rather than probing and grabbing information out of it, would it make sense for the sidecar or the ephemeral pod or whatever to be dropping SNMP packets onto the simple network management protocol or simple network monitoring protocol? SNMP is a very lightweight protocol, and it's ancient, and many things use it, and even Prometheus can read that data and present it in real time. So I'm wondering if we're considering some of these ancient things.
We could try to put that also as a part of the KEP, but then I think I was thinking more on, will Kubelet still be involved in that, right? Like it feels like you're shifting the responsibility of who's checking that this is working correctly to, in that case, what would that look like? I mean, it's not a bad idea, but then the semantics of how it looks like today and the fact that it's Kubelet who is finally dictating the status on the pod would change, right?
Or maybe. I mean, because you could pull out the data and then drop the SNMP data where you want it.
Yeah, or that, yeah.
It probably is, but, I'm always advocating for SNMP.
So lunch is starting now. We can stick around and keep answering questions if people have more questions, but...
I'm not sure if this is a question or a comment. in all of these, it seems that you run the very real risk of suddenly changing probes indicating that the thing is ready to be an endpoint on the network. And that's a little disconcerting because that particular aspect of probes, at least from my point of view, tends to be a little important. And what are you, I recognize that, I think it was you actually who was pointing out that, you know, there is that semantic, we should perhaps consider that semantic separately from how it is implemented. But it does seem to me that that is a particularly important semantic to maintain. We already see plenty of situations where a pod will pass readiness and not actually be ready to be an endpoint in a service, and that causes a lot of problems. Right now, it's usually because somebody misconfigured the readiness probe, or because they've allowed the pod to respond true when it's not actually ready. But this seems like it could make that more common.
Yeah, you know, part of the answer to that is that probes already don't work that way, particularly because if you have network policy that applies to a pod, then it's possible that Kubelet will be able to access the pod before anybody else can, in which case, you know, the readiness probe would complete, and yet it wouldn't be reachable. You know, the other thing is what we were saying about the fact that it's reachable from within node does not mean that it's reachable from other nodes. Maybe there does need to be some better way of proving reachability, although, you know, you don't want to delay until you've proved that every node can reach the pod. So yeah, I don't know what the best answer is. But yes, I recognize the concern that this might cause pods to claim readiness before the network plugin has fully wired them up to everything.
Yeah, I recognize that that does happen right now. And to your point about, especially if you have auth policy in place, the nice thing about those situations is that right now you can almost always point at a situation where you can say either you've miswritten your probe entirely, so it's the fault of the person who created the pod, or you've done something strange with auth policies. Usually you get to say one of those two things, as opposed to, oh yeah, that's just the way probes work, which feels like it would be a harder sell in a lot of situations. Thank you.
Yeah, I think as I'm thinking about this, just jumping off a little bit on that real quick, I think that that's what we need to do is to, like, as a Kubernetes community, to declare, like, this is how probes work, this is what they're for. If you wanted to do something else, you should do something else, just so that we have, like, we can narrow the scope. I came back up here because in thinking about it, and specifically I'm thinking about Sasha's point about, I think implicitly about Kata, but then also a little bit about like Windows containers, like other sort of non-Linux containers. I find myself actually leaning more towards the probing sidecar piece. Like we were chatting a little bit, and like, you know, obviously there's an accounting problem of like, you know, how much should that container have inside of the pod, but that actually answers the accounting problem that we currently have, which is like we're charging the infrastructure for, you know, what is actually workload behavior, and that's like going against the system C group, and so like that's like, you know, means that the nodes need to have like weirdly accounted for resources. So obviously there's like a question of like how much should you give a probing sidecar, but if we can answer that question well, then we can actually properly account for the amount of overhead that like probes like do, and that's good. And then also it feels like a tighter solution because that entity is in the pod network namespace, so we have like a very succinct answer, like is the, you know, we're answering the question, is this pod like, is the server running over localhost? That's the answer that we're answering, and then anything else like would have to probe from externally, which we're not even doing anyway today. And it's like feels like a clean solution. So I've moved. I'm voting for this.
And you're not worried about the weirdness of Kubelet?
We're doing that already with the infra container, and obviously like I'm personally like advocating we drop the infra container for most cases, but like there are cases we'll need it anyway. So it's like not like, and so this is not unprecedented where the Kubelet like does something interpreting what like the pod spec means, but then like doing something on the side because like we need to do that. So like that's not I don't feel like that's too much of a problem, as long as we can figure out the accounting piece of it, because the pause container takes like practically no resources, and this would take some resources, so we need to like sort of figure out how to interpret like, you know, the resources the pod is allocated, but be able to take a little bit of a slice of it. But once we've solved that problem, it feels more idiomatic to me.
I have a possible answer for that, actually. So possible answer, haven't thought about this too much, but it just came to me as we were talking about this for the sidecar situation. What if instead of a sidecar container, we use the unshare syscall to sort of run a process in the net namespace, like run a go routine in the pod net namespace to do the probing?
As like part of Kubelet?
Potentially, yeah. Is that worse?
You're overwriting the CRI.
Yeah. You're assuming that containers are implemented in a particular way. Yeah.
That's fair. Yeah. Okay, fair enough.
I just want to kind of say that I've been personally looking into this problem for a long time, and I just want to say what we ended up looking at and some of the use cases like around this that we have.
Which problem specifically?
Like the problem of the probes, how they work, and the fact that the kubelet is assuming they can talk directly to the pod, which is not an assumption we have in the way we run things today. So we had to poke hole through our network security for a long time in order for this to happen. And over the time, we have evaluated different things. One is the NSCenter patch that you mentioned. We have a patch to the kubelet that is doing NSCenter in order to kind of exec like the probe into the container today. It works, but as I said, like it only works on Linux. And we also run micro-VM and Kata, and this is why like we look into making this part of the gRPC API of the container runtime. I think my experience is if you're going to go for the sidecar approach, if you want to go like with whatever thing, let's make it part of the responsibility of the runtime versus like making assumption in the kubelet, because it's going to be very different depending on the runtime that you have there. We ourselves, we have not looked into patching the runtime right now because it's an effort we would like to drive with the community. But if we have a gRPC interface that is specifically about probes, this is going to be lead any implementation of the runtime, choose the best solution to deliver these. Like, of course, as you said, you can shortcut everything, do NSCenter in the container runtime for a Linux-only word, or like potentially drop a specific container. I also want to say something about accounting. You're all right about accounting, but what happens if you have a very intense probe? And coming through the experience of overhead in runtime classes for micro-VM, we run databases, for instance, if we have different like runtime classes with different overhead, depending on the how they do on the storage. Same problem we will have with the probes. There is no size that fit all. So that means that we need to go and change the API we expose to the user in order to decide how many resources they want to have there. So even the accounting problem, why it's very good to solve it, I would like to decouple and maybe considering decoupling it from this specific implementation, because otherwise we're going to have to take on a lot of API changes in order to let user customize how much resources their probe needs. It's not going to be 100 millicore or 128 megabytes of memory for everyone. Maybe you're going to have different sizes there. Just because we've been looking into these things as well, I just want to share like our experience and why this is a very hard problem. And maybe decoupling the semantics from the implementation is great. And I feel like however we deliver it, I feel based on our experience, probably working on the runtime could be something very good versus hacking around the runtime.
Okay, thank you.
Sorry to interrupt, you know it's lunchtime, right?
Yeah. Yes.
Yeah.
Did you want to say? All right.
Thanks everyone for coming.